Alright, so here's a cool little picture. And let's just move it over here. Alright, so let's put some stuff in here. It says, what does it say about this? The base of a regular pyramid. When it says it's a regular pyramid, it means the bottom of it, all the angles are the same and all the sides are the same. Okay, so it's not a rectangle, it would be a square if it's 4 sides. Okay, plus they tell you it's a square. It's a square with each side measuring 4 centimeters. So let's put that on there. So that is 4, and so on. I don't need to put the other ones on there. You get the idea, right? And it says the slant height of the pyramid is 5 centimeters. That's the thing. That's a little bit different with this. Let's do this in red so it doesn't blend into everything. No, it's not the dotted line. The dotted line, that starts from the top and it goes perpendicular to the base. So that would just be the regular height of this thing. So if you were doing volume, remember volume is the area of the base times the height, then that h right there, that's the height of it. Does that make sense? But this time we're doing surface area. I guess I should have written it on here, shouldn't I? We're doing the surface area. We're not doing the volume of this. So surface area is a little bit more involved on this than the volume. Volume would be pretty easy. It's the area of the base, right, times the height. So whatever the height is, you multiply it by the area of the base. Area of the base is easy, 4 times 4. So 16 times h, whatever that is. Now, it's a pyramid, though. So what is it? It's not just the area of the base times the height. If it was volume. We're not doing volume, but what if it was volume? It's the area of the base times the height, and then divided by 3 because it's a pyramid. Right. Now, if the thing went straight up, it was flat on the top, okay, then you would just go the area of the base times the height, and that would be it. But it's a pyramid, comes to a point, so we divide it by 3. But surface area, we're going to have to take a look at all the individual surfaces. So what do we have? We have the bottom, right? And that's easy. It's just a square. 4 times 4 is 16. So that's the bottom. We can do that in our heads. It's pretty easy. Plus, basically, you could say lateral surface area, but let's just do this. Let's just take, here's one side. How many sides are there? This is one side. There's 4 sides, right? Okay. Yep, because there's 4 of them. All right, so it's going to be 4 times what? What shape is this? It's a triangle. Okay, so what we have to do is we got to find the area of this triangle right here. You follow me? Okay, and then multiply by 4. Why do we multiply by 4? Because there's 4 of them, right? There's 4 sides. Okay, that's why. So we could say this. So area of what? Triangle. Okay, we'll put like that. Does that make sense? It's not like you have to memorize this formula. I'm just trying to get you to understand what we're trying to do here. We're trying to find the area of the bottom of this plus the area of this side plus this one, and this one. All right, so we just multiply them by 4 because all the sides are the same. Make sense? Okay, so the bottom, that's easy. We already said that. What's that? 16, right? So really all we got to do is find the area of this triangle right here. Well, what do they give you? They also give you the slant height. If you look at the book, they tell you what the slant height is. It's different than the regular height. What is the slant height? It's equal to 5, right? So it's not from here straight down to the bottom. That's not what they're giving you. If I can, I don't know if I can make this look right, but it would be basically that height right there. Do you see it? It's kind of sliding down the side of the pyramid. So if you sat on top of the pyramid, went for a ride, straight down the pyramid, the side of the pyramid, then that would be the slant height. From here, and it's also, what do you think? It hits perpendicular to this. Do you see that? Okay, so that red one right there is how much? It's 5. So basically what we have here, I should have had one of these drawn already, but basically if you want to look at like completely from the side, because if you look right smack in the middle of page 22, do you see that? They have a triangle drawn, and let me just flip this around a little bit. Sorry for the let's see, reflects, no, let's see, how do we do this? Does it rotate? No, I don't want to rotate it. Well, anyway, I should just be able to flip it over, like, hold on, let me pause this and I'll figure out how to do this. Alright, so I drew that thing. Now, what did I just draw right here? I just drew a triangle, but what am I trying to show? I'm trying to show just this side right here. Now remember, it is slanted, isn't it? It's slanted in a little bit, but what do we know? We know the height of this, which is what? 5. So if I drop this to this, that would be 5. Now what's the bottom of the whole entire thing? It's 4. So from here to here would be 4, wouldn't it? And we just have to find the area of this. That's pretty easy. So how do you find the area of this triangle? It's 1/2 the what? The base times the height. Okay, so half of 4 is 2 times 5 is 10. So the area of that is 10. Well, let's go back up here. We said the bottom of this pyramid was 16 plus, since that's in red, let's go back to red, plus what? 4 times the area of just one of the sides. We just figured out one of the sides, which was what? 10. So that's 40 and 16, which is what? 56. So the surface area of this whole entire thing is 56 square whatever. Let's just say it's in centimeters. I don't know what they say, but let's say it's centimeters, so it's what? Centimeter. It's area. Area is squared, volume is cubed. Okay, so it's just 56. Whatever the units are, we'll say centimeters squared. Okay with that? So there's really no big fancy equation that we're using on this. So you just have to kind of break it apart, you know. Say, all right, let's find the area of the bottom, right? And let's find the area of all the sides. Well, what shape is that side? It's a triangle. How to find the area of that triangle? Don't take the height of the pyramid, take the slant height of the pyramid, because that's the same as this side right here. Make sense? So basically we're just taking one of those panels off of that pyramid, pulling it out, flattening it out like this, and so this would be 5. The bottom obviously is 4, and then that's easy to find the area of the triangle. Multiply it by 4 because there's 4 of them, and then you add them all up and you get 56. Make sense? Alright, that wasn't really tough. That was pretty simple. You don't have to do a third of anything. But again, when would you do the third? When you're doing what? Not area, but volume. That's right. Okay, if I had to find the volume of this thing, it would be the area of the base times the height, not the slant height, but the actual height of it. And I think they even tell you what the height is, do they? No, they don't. But let's see, you could figure it out though, couldn't you? Yeah, you could. Let's think of this. Just for fun, let's think of it. If this is the height, what if we did this? Boom, 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 boom. Now, it doesn't look like it's a right angle, but it is. This hits perpendicular to the base. Do you see that? Alright, so what do we have here? We have a right triangle. I've got this height, I've got this little bit right here, and I've got this slant height. So really, what we have here is we have a right triangle. Let's try to draw that. Alright, so that would be the, oops, let me try that again. That would be the height. That would be that little bit going across the bottom. And then this right here would be what? The, give me the word for it. What would this be? See, this is the regular height. This is, yeah, this is the little bottom part. What would the little bottom part be? Yeah, but how, I'm sorry, you're right, it would be the base of that triangle, but how many centimeters? It'd be 2, that's right, because it's halfway. This drops right in the middle, okay? So from here to here would be 2, so that would be a 2. And then we know the slant height. This would be our slant height right here. Do you see? They're different views, aren't they? It just depends on your perspective of how you're looking at it. So that would be a 5 right there. And now we could find the height of this thing if I wanted to find the volume. They don't ask you that in this example, but they could, couldn't they? Right? And given that information. So you find the height. How do you find the height? We remember that's perpendicular. What would you use to find the height? I don't think we've discussed that this year yet, but you should have in Algebra 2 and even Algebra 1 and geometry. Yeah, Pythagorean theorem, okay? Pythagorean theorem. So let's do this real quick. So what would it be? It would be, yeah, let's do the h first. H squared plus 2 squared equals 5 squared. Okay, so h squared equals, what's this? 25 minus 4, which is what? 21. Everybody see that? What I'm doing? Take the square root, so what's h? It's the square root of 21. Why would I need the height? If they ask you to find the volume, you have to find the area of the base times the height. So the area of the base would be 16, that's easy, times the height, which would be the square root of 21. Everybody with me? And then you take that number and divide it by 3, chuck all that in your calculator, and you'll get some decimal answer. We don't have to go through all that.
Square root form?
It's probably better that you put it in a calculator, because you're going to have, but basically what you would have is this. You'd have the volume is the area of the base, which is 16, right, times the height, which is the square root of 21, divided by 3. I guess you could technically write it like that. It's probably better if you threw that in a calculator and got a decimal. Okay, would I accept that? Sure, I would accept that, but it might be better if you wrote it as a decimal. We good with that? All right. Now let's talk about spheres. Let's pause this just for a second. All right, check that out. Nice, pretty sphere right there, colorful and everything. What I did is I put it in a what? It's sitting inside a cylinder. Look at the cylinder. Okay, the sides touch right here, and it's kind of hard to imagine this, but the top of it, the top of the sphere or the ball, whatever you want to call it, touches the top of the cylinder. You follow me? So it touches on all sides. So it's not like it's too small for the can. It fits perfectly in the can. Right? You've got the bottom touches the bottom. The bottom of the sphere touches the bottom of the cylinder. The top of it touches, and the sides, they touch exactly. Okay, it's not smushed in there, and they fit exactly. The reason I did that is because there's a good relationship between the sphere and the cylinder. Do you remember what the volume of a cylinder is? We just discussed it earlier. It's what? It's the area of the what? Of the base, not of a cylinder. It's not divided by 3. That's only if it was a cone. All right. But a cylinder is just the area of the base times the height. Well, check this out. This sphere right here, does it take up the whole entire cylinder? No, it doesn't. For instance, let's say we filled it up with water. Okay, so you'd have all this empty space and all this empty space. You follow me? All this and all this and so on. You get the idea? So it doesn't take up the whole thing, but it takes up a whole lot of it. Do you think it takes up more than a third of it? A cone only takes up a third of that cylinder. Yeah, it actually takes up exactly twice as much as what the cone takes up in the cylinder. So that means the cone took up a third, so this takes up 2/3. Okay, so this volume right here, tell you what, let's just kind of scooch that over so I can put something in there. All right, so this takes up exactly 2/3 of the whole entire cylinder. So really, that's all you got to remember is the 2/3. That's what's cool about learning it this way, is that it's the area of the base times the height, but then you take 2/3 of it. So basically, you multiply it by 2, then divide it by 3. That's taking 2/3. Does it make sense? Well, what is the base of this, though? The area of the base. If this is a sphere, what is the shape of the base of this? It's a circle. That's right. So what is the area of? So let's do this. I'm going to show you another way. A lot of teachers have you memorize this next formula. I'm just going to show you where it came from instead of just saying, okay, here it is, memorize it. I like learning it. It's 2/3 of the area of the base times the height, because then you can always find the area of this base if you know the radius. Multiply it by the height. What's the height of this? If you know the radius, and let's put a radius in there. Let's say from here to here is the radius. Okay? And what if that radius is, let's think of a nice little number, 5. Let's say the radius of that base is 5. Then look, you got everything you need to know. That's all you need to know, is just what the radius of the sphere is. You could have gone from here to here, that would have been 5. From here to here, that would have been 5. You with me? Or I could have gone from the bottom all the way over here, and that would be 5. Let's think about the height. The height would be from here to here. Knowing the radius actually gives you the height. What do you think the height is? Remember what the radius, if that's the center right there, the radius goes down to here, so that would be 5, right? And so from up to here would be 5, so the whole height would be 10. They don't even have to give you the height, do they? They just have to give you the radius, and you can figure out the height. Make sense? Alright, so let's plug some stuff in. What I'm going to do right now is I'm just going to show you another formula. If you want to memorize this formula, you can. Feel free to. But a lot of books just throw out this formula and say, here it is, memorize it, and they don't really go through a lot of pain to show you where it comes from. But I'm going to do that. Oh, I sure am. I better stop.